Hey guys, in this tutorial series, we're going to make a Breakout clone. So we're going to use only FlowCanvas. We're not going to do any custom scripts or use any other plugins. And we're going to make a full functioning game, which should hopefully also be quite fun to play. So in part one, we're going to look at the project setup and we're going to implement the basic fundamentals of how the game works. So the player moving the ball, bouncing off of walls, bouncing off of the paddle, and bouncing off of these bricks. All right, so the theme we're doing for this breakout game is these kind of bricks, like kids playing bricks. And we have some nice assets that we've downloaded for free. And they come in various sizes, various shapes, and various colors. So this is going to be very useful. So you see here we have our paddle, we have our ball, and we have our bricks. Now, right now, there's absolutely no behavior on these. They just kind of exist in the scene. However, there are some components that are on each to make them ready for us adding the behavior. So I'll go through those. So first of all, I'm using pixels per unit 32. So when we're working with 2D, it's important to make sure that we have this consistent. So 32 pixels per 1 unit. And because of that, I've also set my camera size to be 32. My walls basically just have a box collider, nothing else. That's fine. So you can see here, they will have a box collider. My paddle, I'm thinking we might want to add a power up that allows us to extend our paddle like this. And so each of these have a box collider 2D on them. And the paddle itself has a rigid body, a kinematic rigid body, because we're going to be moving this ourselves. We don't want dynamic physics to be affecting this. And I have a composite collider 2D on this as well, which basically combines all of these sub colliders into one rectangle collider, as you can see there. Now for the ball, since the ball is actually going to be using Unity physics and bouncing around, we have it set as a dynamic body type. And we've also put the collision detection to be continuous and interpolate to be interpolate. This should make it more solid as it calculates its collisions. It would prevent some clipping through objects. And we've frozen the rotation on this ball, on the Z, so that it doesn't spin around. We don't want it to spin around, we want it to remain upright and just move up, down, left and right, no rotation. And for the bricks, similar to the walls, they just have box collider 2Ds on them. Very simple. So since we're not actually going to use gravity, we don't want Unity to calculate that. And so I've set gravity to 0 here. You can also set it on the ball itself, have a gravity scale of 0. But basically, we just want to make sure that we don't have Unity's gravity messing with the velocity that we set. And one other thing I've done is I've created a default physics material here. And I've put friction to 0 and bounciness to 1. And that's going to make sure that our ball will bounce off of walls or bounce off of bricks or the paddle itself without losing any velocity. All right, so that's the basic setup. So now we can start adding behavior by using FlowScript controllers. So let's start by setting up the ball. So I'm going to grab the ball and I'm going to add a FlowScript controller, create a new bound graph, and I'm actually just going to move these up to the top. So let's add an onStart event. So in events, graph, onStart, and we want to grab our rigid body 2D, drag it in, and let's search for velocity. So we're just setting our velocity. And we'll connect that flow up like that. Now that little green south means that it's going to be looking for that rigid body 2D on the ball, which it has. If I remove that, and that goes red, and that shows us that it hasn't found that, so it's going to be an error. But we do have one, so we should be completely fine. To decide the starting velocity of our ball, let's make a vector2 variable in our graph. And that's going to be called starting velocity, like that. And we can expose that. By exposing that, we can now simply click the ball, click this here to override our variable, and we can make that whatever we want it to be. So in this case, set it to start at 20 on the X and -40 on the Y. And we just want to connect that up to that value. So I'm going to drag that out, get our starting velocity and plug it in to that value input there like that. All right, so let's go into play mode and just make sure it's working as expected. So there we go, it has set its velocity. And it's bouncing off the walls. And if we check its rigid body, you can see here we have the velocity 20 and 40. And when it hits something, because we have the friction set to 0 and the bounciness to 1, it reflects exactly and it will retain that velocity, which is great for this kind of game. We want more consistency in our physics. And of course, if we wanted to, we could change that starting velocity to be even higher. So let's double it. We can just set that parameter there, play, and there we go. All right, so the ball is working pretty good. But what we really want to be able to do is move this paddle left and right in order to hit it. So let's go into our paddle and let's create another FlowScript controller and again, make it bound. So for the paddle, we want to detect the player input, so left or right, or A or D on the keyboard, and we want to store this in a variable. So what I like to do is I like to create a variable. So I create a float, and this is going to store our input direction. So when input direction is 0, then the player is not pressing anything. -1 going left, +1 going right. Now, since it's physics, I actually want to do this in the fixed update. So I'm going to create a fixed update event like that. So what I want to do is I want to use get key. So I search for get key, and here I have my get key with my key code. So I've got that. I will copy paste it because we want to support AD or left and right. And again, these two, which are for my other direction. So A and left, D and right. So let's just assign those really quick. So here, A, and this one left arrow, then D, and right arrow. And here we're going to use an OR. So search for OR, and we want to use the function OR, not the flow controller OR. The function OR will let us put in 2 booleans like that. And we'll copy paste that down here for the right movement as well. And basically what we want to do is we want to set our input direction to 0 at the beginning. Drag that in there like that. And then if we have A or left arrow down, we're going to subtract 1 from this. If we have D or right arrow, we're going to add 1 to this. So here, let's add a switch condition like that. Plug that value into there. Copy paste, plug that value into there like that. Now we can grab our set variable node here, copy paste it. And here, instead of set, we're going to do add. So add on the bottom one, because the bottom one is right or D. And on the top one, where it's A or left, we want to subtract. And we'll just put in 1 and put in 1, just like that. And connect that to the true flow like that. Now, in retrospect, we don't actually need this to be a float. This can simply be an integer because we are only expecting -1, 0, or +1. And so what we can actually do is we can click this and we can click change type system and change it to an integer. And then for these, we also can just change these to an integer. So I'm just right clicking, changing the generic type, set variable integer, reconnecting that variable like that. And that should be a bit cleaner. All right, so let's connect them up. So first, we can drag this into here. And now this has to work in sequence. So we cannot drag this into there, right? We would have to drag it around like that. And so what we're saying here is we're getting our left and then we're getting our right. However, we do have a couple of options because this may not look that clean. So if we instead wanted to order it vertically, what we can do is we can delete that and we can create a split flow controller instead. For now, I'll just give it 2 ports. And now I can feed that into there and I can feed that into there. And what that's doing is basically the same as before, except it's a little bit more neatly visually organized. So it's going to do this one, then it's going to do this here. All right, and when I change this to an integer, I did accidentally have this back to set, so I've just put it back to subtract, and this one back to add. So we're subtracting, and you can see here, input direction minus equal to value, which is 1. I'll just drag that out to make it big, a bit more visible. And now what we want to do is apply this input direction to our rigid body, but we also need a speed variable because we're not going to apply it exactly like this, right? We want to apply it the direction times the speed. So let's go into here, create a float. So this one will be a float. I'm going to put that above the internal ones, and I'm going to call that movement speed. And we'll set a default value of, let's say, 30. I'm not sure what's going to look good. We'll adjust that later. And then we will expose that public so that we can modify it again outside just here like that. And we can fine tune how it feels. All right, now in this case, it's a kinematic rigid body, and I want to use the move function rather than the set velocity or force or anything like that. I want to have complete control over this and basically just set it where it's going to be. So what I will do is I will grab the rigid body like this, and I will call the move position. There we go. And so all I need to do is calculate where my new position is going to be. All right, so I have my movement speed and I have my input direction, so I can grab both of these. And I want to multiply these together to get me the movement delta. And we want it to result in a float, so make sure that when we call that multiply, we choose the float multiply, not the integer multiply. Now, because this is happening in fixed update and I'm moving it directly, I need to also apply, I need to multiply it by fixed delta time. So we have fixed delta time here. I'll copy paste this and multiply it there like that. So now I have my delta relative to my update frame. And I want to get my original rigid body position. So I'll grab my position here. So search for get position. There it is. And I can drag that out, extract it. And I want to add to that X, so I'll drag that out as well. Plus, like that. Then I'm going to construct my vector 2, so new vector 2. So I can use extract to basically expose all the variables inside, and then I can use new vector 2 to reconstruct it. So in this case, we want the y to be whatever it currently was. We don't need to worry about that. And for x, we want our current x added to what we just calculated our movement delta to be. And then we just move that into our position. All right, and so now what I want to do is connect that up. So I have a couple of options. I could add another port count here and drag this out and connect it in there like that. Or I could use the then on this second port. So whether this is true or false, doesn't matter. I'm going to go through and I'm going to move that position like that. All right, so let's play and see this in action. So as you can see, these values here are updating as I press different buttons. So when I have A pressed, it's gone to true. And you can see these flows change depending on that. And if I have both of them pressed, well, it's going to add 1 and subtract 1, resulting in 0, meaning no movement. So there's no bias towards which direction we're holding, which I usually find is pretty nice in a game when you don't have a bias. And of course, I can also modify my movement speed there, so I'm much faster. Right now, I can basically catch the ball or deflect the ball by lining my position up with it. But we don't really have any logic right now for the ball depleting your life when it hits the floor. We'll do that later. Another thing to note is that the paddle is not constrained to the play area, which is not ideal. So we want to sort that one out as well. So in order to prevent our paddle from going through the walls, we need to kind of know where that edge is. And that way we can clamp our X position based on that edge. So we're not going to calculate the actual collision, we're just going to clamp it based on what we know. So what I think would be useful to do is to create a config blackboard. So we're going to create a new object, and we're going to add a global blackboard to this, and we're going to call this game config. So now this blackboard, we're going to add variables directly in the inspector here. So I'm going to add a float, which is going to be game top edge, and I'll just duplicate this a few times, and we can call this bottom edge, left edge, and right edge. So the idea is that these edges are going to be lined up exactly here, 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 and here. And that way, if we ever need to constrain anything, or if we ever need to do something without relying on our physics, we can very easily do that. And for now, just to be clear, I'm going to call this game config global blackboard. All right, and now we can set these values here. So for now, we're just going to do it kind of manually, but later we'll have a better system put in place for that. So as you can see here, this is the center of the wall, which is not actually where the edge is. The edge is the center plus the extents, which is this here, which is basically our scale divided by 2. So 2.5. So it would be negative 55 plus 2.5. So let's have a look over here. So left, negative 55 plus 2.5. All right, and just to confirm that, we'll create a variable here, and we'll put that value in like that, and you can see there it lines up perfectly with that wall. And of course, our right edge will just be the opposite of that, so positive 52.5, and then our top is going to be 30 minus 2.5, and our bottom is the inverse of that. All right, so now that we have those values, we can clamp it. So right now we only need the left and right wall. So here, before we do our move position, we can clamp our new position. We don't really want to move our rigid body, then move it back. We can do it before we move. So because it's in a global blackboard, I can access it from any FlowScript controller. It doesn't belong just to my object. It's globally accessible, which is very useful. So here, if I go into variables and I choose blackboard and I choose game config, you see I actually have access to them all right here. I don't even need to remember their name. So here I'm going to get the game left edge, then I'm going to copy paste that, and game config get game right edge. And what I want to do is I want to clamp my X value, search for clamp. We're clamping a float, and we have our minimum as our left and our maximum as our right, and our value is here. So before we apply it, before we put it into our constructed vector 2, there we go. However, there is one thing that we need to remember, is that the position is from the pivot of our object, in this case the center. And so this is only really clamping it to the center. We need to factor in the extents of our paddle. So I'm going to press space and search for bounds. So we're going to get bounds. Now it's a collider 2D. So again, it's green because it has found a collider 2D on our object, which is our composite collider 2D here. So we're going to get the bounds of our composite collider. All right, and now we want the extents, because the extents is going to give us basically half of the width and half of the height, which is exactly what we want. In this case, we want the x-axis. All right, so for demonstration, let me just use this. So if this is our wall, and I'll just grab this, and this is our paddle, what's happening right now is that it's going to be constrained on the left exactly here, right? And what we want is we want to say, well, I want to constrain it here plus half of what this is, so that it would be like that. So here on our left edge, we say add, so float add, and we want to add our extents, which is this. Again, our extents is half of this. And on the right side, so on the right side, it would be doing this, so we need to bring it negative so that it's inside. So now we add a minus float, and we want to say our game right edge minus our extents, like that. There we go. And let's just delete that example there. All right, and now this is getting a little bit complex, and so what I want to do is I want to make it a bit clearer what's doing what. So I'll just move these over into their own kind of block here, like that. And I'll just wrap. So I'm holding Control and dragging to create a box here. And I will just say clamp X to left and right of the game area, like that. Whereas here, I'll do the same thing, holding Control, dragging, and this is calculate the new position. And we can also do this, which is gather player input. So now we can very clearly see what each of our sections is doing. And this is very useful because if we have a bug in the clamping, then we know we only need to look in this area. Whereas if we have an input bug, we can look only in this area. We can also just tick on auto to make them auto scale to their content. And that can look a little bit nicer. And there we go. So now, even though I'm continuing to hold left, I'm not able to go through there because we're clamping that position very nicely before anything happens. We'll never get any overlap, and our position will never ever go past that collider. So one thing that's kind of bothering me now is that there's a gap between the paddle and the floor, and I really want to get rid of that, but I don't want to have to position this every time manually. And now that we actually have our top, bottom, left, and right values in our game config, I can leverage that to do something very similar to what we were doing with the clamping. So what I will do is I'll add an event. So we're going to use a onStart event. We only want to do it once. We don't need to snap it to the floor every frame. Once we've done it once, we don't have any movement that's going to take it off the floor. So let's just keep it simple and do it once on start. So I've got my onStart event, and I'm going to come down here and copy my get extents. We want to use this. And in fact, I will grab all of that, bring it over. Now, in this case, we are worried about the y-axis, the extents of the height. So half of the height. And we don't want the game right edge. Instead, we want the game top edge. There we go. All right, and the final thing we want to do is we want to move position. So I'll just grab that node, move it over here. All right, and then we just have a minus, so float subtract our game top edge minus our half extents there, and that's going to give us our y. So let's create a new vector 2, drag that into there, and we can just keep our x-axis at 0. That will just mean it's centered, so that's fine. And then we apply that position, and of course we need to bring that in there like that, and that's going to happen, as the node says, once. So because we're working with physics, things do get a little bit tricky, where even though we set our position here, the position that we get in our first fixed update is actually the previous position, which is not ideal. So what we can do for that is we can add a Boolean to make sure that we cannot start moving until we have initialized. So what I'll do here is add a variable, so bool, call it initialized, drag it into the graph, and we're going to set it over here, and we're going to get it down here. So here we'll create a switch condition, connect that in like that, and only if it's initialized are we going to allow our input and our movement to happen. And then here we want to set initialized to true, but we actually want to wait one physics frame. So we can just wait for a physics frame like that. Very handy node there. So now when we enter play mode, our paddle gets snapped right there onto the top, and we cannot move any further left or right. And that works very nicely. We can catch that ball, and things are starting to shape up. So that's it for part 1 of this series. So we focus mainly on just making sure that our ball can bounce off our paddle and off of the walls, and that our player input is working fine with clamping. So in future parts, we are going to iterate on these to make them more robust or solve problems that emerge as we implement other behaviors. So going forward also, our game config is going to be far more involved in the generation. We're going to make sure that everything is in sync and we don't have to manually upkeep anything. For example, these walls, they'll be dynamically placed exactly where we set our screen edge, and our screen edges will be placed depending on our generation properties for our bricks.